So as you stand by the side of the road, a car approaches you at a constant speed, sounding its horn. You hear a frequency of 80 hertz. After the car goes by, you hear a frequency of 60 hertz. So what is the speed of the car? Okay, so Doppler effect. This is why we hear different frequencies. Our equation for the Doppler effect, the one equation fits all. You can also use the equation from the book, that's fine. F is the frequency that you're hearing because of the Doppler effect. F naught is the actual frequency of the sound, the frequency you would hear if there was no motion at all. V is the speed of sound, V naught is the speed of the observer, Vs is the speed of the source. So we're told the frequency we hear as the car approaches, and we're told the frequency we hear as the car recedes or drives away. So we need two equations. We need one equation for when the car is approaching. We don't know what F naught is. That wasn't given to us. The speed of the observer is just 0, since we're standing on the side of the road. We're not moving anywhere. On the bottom, do we need the plus or minus sign? Minus. As the source, the car, is moving towards us, we need the minus sign to represent towards. Our second equation is for away, so it looks very similar. Only in the denominator we end up with a positive sign. So we have two equations and two unknowns. The unknowns are the same though. F naught, the actual frequency of the horn, is the same whether the car is driving towards us or away from us. We are told that the car is traveling at a constant speed, so the Vs is the same towards or away from us. So there's a variety of ways to do this. You can solve for F naught in both equations. So F naught here would be 80 hertz times the 343 meters per second minus V of the source over 343. Solve for F naught here and set them equal to each other. I like to divide the two equations. If you divide them by each other, the F naughts are going to cancel because there's one on top and one on bottom. So we end up with 80 hertz over 60 hertz, which is 8/6. The 343s in the numerator cancel. If since this is in the denominator of the denominator, that goes up to the numerator. And then we still have the 343 meters per second minus Vs. You're going to end up with the same equations if you solve for F naught and set them equal to each other as well. Okay. Once we're at this point, we just want to cross multiply. So we don't have anything in the denominator anymore. So we get whatever 8 times 343 is, minus 8 times the speed of the car. Get the speed on the same side, so 8 over here, 8 plus 6 is 14. Take this to the other side, so we get 8 minus 6, which is 2, because they don't need to. That's 8 minus 6. Since they're both multiplied by 343, we can factor the 343 out, so 8 minus 6 is 2 times 343. Divide both sides by 14. Speed of the car is 49 meters per second.